No more messing around. We're recording. No more messing around. All right. So this is such a casual lesson. I'm gonna try to sit down for the whole thing.
Mr. Laman, becoming a real teacher, I don't like it.
Here we go.
Crossing his legs too.
Yep, because I'm an adult as well. So our learning targets today. Students will be able to factor difference of two squares. Students will be able to factor perfect square trinomials. Do those learning targets look familiar?
No.
Yeah.
Yeah.
Hmm.
If they're supposed to, they definitely.
Right answer.
I mean, yeah.
Look, same learning targets as yesterday.
Wow.
That might be a typo. Order of operations today. We have one new idea. One. And then we have a couple examples. I think there are 3 of those. Or 5, I can't remember. And then there are 3 practice problems. And guess what the practice problems are on?
Hey, I love mathematics so much. I love it.
I can't wait. All right. Also today, didn't have time to put these in a fancy form, so sorry you get screenshots of the textbook.
Huh?
Here's our new idea. Yeah, our new idea. We ready? Whoa, actually, let's do some cool review before we do this new idea. Yeah, just for a second. What is, let's play a game, okay? I'm thinking something. You guys need to read my mind. What is the property that says that if we have 3 numbers and add them, what?
5 look here.
That's not 5. That if we have 3 numbers, add them together, that I can change the order of these numbers and my value won't change. What is that property called? I like that idea because we're going to talk about, we're talking about factoring. What is it? No. What is it called? Or even if I have multiplication. I can change around the order and we get the same value. Or even if I have addition and subtraction. If I have addition and subtraction. Come on, what is it called? What is it called?
I don't.
Addition and subtraction are... Yes. As far as moving things around.
Common fact.
They're commutative.
No.
The commutative property tells us that if we have all addition and subtraction, we can move things around however we want. As long as we keep our negatives with our negative number and our positives with our positive number, we're all good. We can move things around. Yeah, I'm not sure what that is. That sounds like a disease.
Tuberculosis.
So we have to keep that in mind when we're looking at what we are talking about today. Now, with that said, here is our new learning, or new notes. So you don't have to write down this sentence up here. I would just write down the example as I go through it. To factor polynomials with 4 terms. So far all of our polynomials have been with 3 terms, right? We talked about a form that looks like this. Right? All of our polynomials that we factored have been 3 terms, or trinomials, or some of them have been binomials, with 2 terms. So today we're learning how to factor polynomials with 4 terms.
Is that quadnomials?
Sure. Yeah. To factor polynomials with 4 terms, group the terms into pairs. Factor the GCF out of each pair of terms, and look for a common binomial factor. This process is called factoring by grouping. So all it's saying, look, example A, this is what I write down. They give us a polynomial that has 4 terms. Right? And we can't, like, right away just up our parentheses and start guessing and checking and doing all those things that we've talked about. We have to first group these in pairs. Alright, so as you can see, they group together our 3x cubed, or our x cubed plus 3x squared, and then our 2x plus our 6. Why do you think they decided to group together our x cubed and our 3x squared? Like, why not group together x squared and 2x? Because why?
You don't have all the factors.
You don't have all the factors.
I'm throwing out ideas.
No, I like it. Keep throwing out ideas. Why would we group together the x cubed plus 3x squared instead of x cubed with like 2x? They both have an x in them. It has to do with the exponent, yeah. If we're trying to, we know we need to group things together, right? We need to have two groups, and then we need to factor out their common factors. We can factor out more with what we have right here, with the x cubed plus 3x squared, because we can factor out an x squared, like you'll see here. If they only group together our x cubed plus 2x, then all we could factor out would be just an x. So we want to group these together in a way where we can factor out the most possible. Does that kind of make a little bit of sense? Group them together so we can factor out the most possible. Now we have our two groups. We factor out the greatest common factor of each one. So the greatest common factor of x cubed plus 3x squared would just be the x squared. Greatest common factor of 2x plus 6 would just be 2. And now they do a little bit of rewriting, where we have, look, an x plus 3, we have 2 of them, and they just write our leftover, x squared plus 2. This is not something that you will be tested on, because it is pretty tricky, you don't use it a whole lot, but it is something that I want you to give an effort on trying to do today. Okay? Why are we doing it? Because eventually, like I think in Algebra 2 at some point, maybe in Algebra 2, you will use this a little bit more. So it's something you have to have seen, but I will not test you on it. So if we look at an example, we have this 4-term polynomial here, or as Michael would call it, what did you call
Polynomial.
it? Quadnomial. We'll pretend like that's a thing.
Thank you.
If we want to group things together before we try to factor things out, what do you think we want to group together?
7x.
Isn't it like the x cubed and the x the 2 with the x
Right here? Yeah.
Yeah.
We want to group together our x cubed, and we have a negative x squared. Then our other grouping would be negative 7 plus 7x. We show a plus sign here in the middle. Here. We're doing what we're supposed to so far. Now, if we look at what we can factor out of this first binomial, what could we factor out? What? What do these things have in common? X cubed and an x squared. The exponent, they both have what? How many x's do both of them have? At least. They both have at least 2, so we can factor out an x squared. Perfect. What can we factor out of this second binomial? A 7. Now, one thing we need to be a little bit careful of when we write these binomials, we like to see them with our whatever value has x first and then the number second. So we really, if we were being totally correct, we would rewrite it like this. Correct? Okay? Okay. Now our last step is where I get that things can be a little bit tricky. If we look at this as a term and this as a term, what do they have in common? They have what?
X.
X minus 1. So what we are looking to do for this last step is factor out an x minus 1. And then we are just left with our leftovers. X squared plus 7. So that would be how we fully factor letter B. Who has time in their life to make up all this?
Yeah.
I don't know. Some geniuses.
Some dumb
Let's.
idiot head.
Yeah?
Uh-huh.
Yeah. Alright, you got them. If we look at letter C, what do you think we want to group? Sky, what do you think we want to group? The slides aren't posted, I don't think, so I don't know. Oh, you take notes on your iPad, don't you? Or look at a blank screen. That's good too. What do you think we want to group, Sky? In letter C. What?
Oh.
Oh, wait.
Hey, Sky got to volunteer everyone else earlier, so I'm going to volunteer Sky.
Yeah. Yeah, that one.
Yeah, and?
The third one.
This one?
Yeah.
Yeah.
I don't know what you do with the other.
We can group them together. So here's our groupings. The common factor of x squared plus x would just be an x. So it leaves us with x plus 1. Common factor between y plus xy would just, would just be y. So we are left with 1 plus x. Again, we want to try to rewrite these so the variable is out front. Now if we look at these two terms, what do they have in common? Those two terms, what do they have in common? X plus 1, so we can factor out a full x plus 1, and then our leftovers are x plus y.
That was amazing.
Isn't that pretty cool?
No.
Now you guys can factor binomials, trinomials, and quadnomials.
Go one way in life.
It's good for you.
Yeah.
You're learning.
Yeah.
Yes, you are. All right, we're going to look at two more. I was right. There are 5 examples. I can't believe that.
No.
We'll look at 2 more. We'll look at letter A and letter B. Letter C, we can save for later. All right, if we look at letter A. Look at letter A. Here's another. This is a little bit of a different type of problem, right? This is a trinomial. But what do we notice? What's different about this trinomial than any of the other ones we've seen?
All of them have X's.
All of them have X's. Good job, Michael. Hey, stay with me. Stay with me. This is our last 2 examples, and then we have that. Last 2 examples. They all have an X. So what do you think we want to do to help get this in a form that we are comfortable with? No, because we're not comfortable without many X's. What? We could right now because it's just the examples. What we'd want to do is, in each term, we want to, remember, our first line of defense with these things is looking at if we can factor out a greatest common factor. If we look at 3x cubed,
Why?
if we look at 3x, if we look at 3x cubed, I'll get it in a second. Riley, if we look at 3x cubed 18x squared, and 24x, what would the greatest common factor of those be? What do you think? Yeah, what can we take out of each of those terms? These first three right here.
What's on the left?
Oh, here.
They're up top.
Whoa.
Pretty close.
Riley, I wrote it on the thing.
What a gentleman, Robbie.
Yeah, 3x. Good job, Lucian and Riley. We take a 3x out of each term. Here we're left with an x squared minus 6x plus 8. Are we able to factor this right here? And everyone together said, yes, we can factor that. Yes, we can.
Everyone said amen.
Our 3x stays out here. And we need a positive 8 at the end, so our factors of 8 are 1 and 8, 2 and 4. We need a negative 6 in the middle, so negative 2 times negative 4 would give us positive 8, and also negative 2 plus negative 4 would give us negative 6.
Wow.
You guys know how to do this
No,
stuff.
yeah.
Yeah, you do. Last example, letter B. There were people still writing that one down. I can zoom back out.
No, sir.
Okay. Letter B. What can we factor out of these two terms? 7x squared. Now that leaves us with an x squared here minus 4. Can we do anything to factor this?
Yeah.
Yeah? What can we do?
Amen.
Remember what we talked about yesterday? We can write this term as its perfect square, right, Tad? Right, Sky? We can write this term as its perfect square. And we could write it in its all the way factored form. Pretty crazy.
That is insane.
Pretty crazy. Maggie, are you Snapchatting about factoring 4-term polynomials?
You should put in your story that this is her favorite
Put on your
class.
story that, hey, 4-term or polynomials are the best ever.
Quadnomials. That's like quadnomial game.
All right, a little bit of practice.
Oh.
Now, I think you joined our class yesterday, so I think it might just show up. Like, no? Are you sure? It says you joined my class in some places.